welcome to my channel Tech Tutorials 2K21. So today in this lecture we are going to learn about the Stressen matrix multiplication in design analysis of algorithms. So Stressen matrix multiplication was proposed by V. Stressen in 1969. So it is a divide and conquer algorithm which is used to find the product of two n by n matrices. So which is used to find the product of two n by n matrices. So before we are going to discuss about this Stressen matrix multiplication, how we are going to find the product of two n by n matrices. So we just recall the brute force approach. Means the direct approach what we are using generally for finding the product of two matrices. Okay, so let us consider the size of n is 2. Now you can take 2 by 2 matrices. So each and every matrix will consisting 4 elements. Right, we have 4 elements in each and every matrix. Let's you consider A equals to some 1, 2, 3, 4, and then B equals to some 3, 4, 2, 1. So you can consider any of 4 elements in your 2 by 2 matrices. So simply how you're going to perform a multiplication, you can take the corresponding row and column and simply you can do a multiplication along with addition operation, right? So simply you can take 1 multiplied with 3 plus 2 multiplied with 2, and then 1 multiplied with 4 plus 2 multiplied with 1, and 3 multiplied with 3 plus 4 multiplied with 2, and then here 3 multiplied with 4 plus 1 multiplied with 4. Simply we can do a 2 by 2 matrix multiplication. Let it take 8 multiplications along with 4 additions. Let's increases the size of n. Like you can consider the size of n is 4. Like you can take 4 by 4 matrices. Like you have 4 rows and 4 columns. So when you are doing like this, what happens? Like every for a corresponding the element in your resultant matrix, like you consider like C 1 1, C 1 2, C 1 3, and C 1 4. And here it is C 2 1, C 3 1, C 4 1. Because when you take a 4 by 4 matrix and the resultant matrix is also 4 by 4. So let you consider like this. So now we can assuming that, so how many multiplications and additions it will take to compute this 4 by 4 matrices for a general matrix multiplication. Like we can see here, for computing this corresponding element value, we can do a 4 multiplications along with 3 additions, right? Along with 3 additions. Like how many elements we have here? We have 16. So how many multiplications it required? 16 into 4. That is 64 multiplications. And then it will take 9 additions for each, means 16 into 3. It will take 48 additions. Okay. So now when n sizes increase and you can increase the size of n, then you can see the number of multiplications and additions also get increased. So how many times it is going to increase? Like you can consider n is 4. Now you can consider n minus 1, that is 2 power, that n power n minus 1, that is 4 cube. These many of multiplications it required. So we know in a computer terms, like multiplication will take more time as compared to additions. So now this is a general method or a brute force technique for calculating the product of two n by n matrices. Whereas the idea behind this Stressen matrix multiplication is, instead of your size n, right? So now it is going to reduce the number of multiplications. Okay. So by that we have to use these formulas. Like you can consider here it is M1, M2, M3, M4, M5, M6, and M7. So in Stressen's multiplication, so we have 7 multiplications, and then it will take how many additions? I already mentioned here, like it will take 18 addition or subtractions. Like you can consider here we have, these are the additions we have, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let it consider 18 addition and subtractions. So this is by 2 matrix. So let's you consider with n by n matrix, like you can increment n size also by using this divide and conquer method. So it doesn't take exponential value of multiplications, right? So that is the idea behind this Stressen's matrix multiplication. Like you can consider, so these are the formulas for performing 7 multiplications in order to find the product of 2 by 2 matrices. Like you can consider here, in place of d you can consider m, so it will be of like this, like m1 plus m4 minus m5 plus m7. So before we are finding the corresponding element of your resultant matrix, so before that you have to find all these m1 to m7 values, then you have to substitute, and then you are performing simply the addition and subtractions in order to get the resultant matrix. Suppose if your n size it get increased, because we are talking about 2 by 2 matrix at initially, now you can increase your n size. So here I am taking 4, n is 4. So that is a 4 by 4 matrix. So how your divide and conquer method will say, it is going to divide a problem into sub problems, and you can solve each and every individual sub problem. Okay, so and after that you can combine to get the result. So now you can see each and every element is represented with a corresponding row and column element here, and here the 4 by 4 matrix is divided into 4 2 by 2 matrices. Okay, you can see this is one 2 by 2 matrix, so we are divided as a 4 parts. So for each and every part, it will take how many multiplications? It takes 7 multiplications. So for doing this part, it takes 7 multiplication, and for doing this, it takes 7 multiplications, and for this also it takes 7, and it takes 7. So totally, how many multiplications it required? It requires 28 multiplications. Okay, it requires totally 28 multiplications for 4 by 4 matrices. And then how many additions it requires? So you can take for one 2 by 2 matrix, it takes 18 addition or subtractions. Now you are divided for, you can divide this entire 4 by 4 matrix with the 4 parts. Like you can consider multiplied with 4. Okay, so simply it will take how many addition or subtractions? Like simply 72 additions it will take. So it reduces the time complexity. Okay, so that is the idea behind this Stressen's matrix multiplications. So let me go through a simple example. We'll try to understand this particular problem. So let's consider this is an example. Okay, so we start with 2 by 2 matrix. For simply understanding this concept, so these are the formulas we have, like A11 plus A22 is multiplied with B11 plus B22. So in a given problem, right, so this is of your 2 by 2 matrix. Okay, this is a 2 by 2 matrix, and each and every row and column elements are represented with A11, A12, A21, A22, and B11, B12, B21, and B22. So what we have to do, we have to recall the formulas, right? We have to recall the formulas in order to performing this multiplication. Okay, so let me consider like this. So now you can see for finding M1, so how we can do? We can take A11 for calculating C12. So simply we have to use the formula M3 plus M5. So what is M3? The value of M3 is minus 4, right? So now for C12, okay, the formula is M3, that is minus 4 plus M5. So the M5 value is 15. So this value is 11. So now this value is 11. So in the same way, you can substitute the formulas, and we are going to find the values of C21 and C22 positions. So C21 is going to calculate it by adding M2 plus M4. So the value of M2 is 22 plus the value of M4 is 12. So now the C21 position value is 36. Okay. And in the same way, you're going to calculate the value of C22. So now it will be like you're going to add M1, M3, M2, M6. So now you can consider that four values. Your M1 is 40 plus. Now M3 is minus 4. Okay. And minus M2 is 22 plus M6 is 9. So now you're going to add these values, like these two are negative values, you can add. Now it becomes minus 26 and this is 49. So now you get the value is 23. So this value is 23. So the resultant matrix C we can consider as 16, 11, 36 and 23. Okay, and the time complexity of the Stressen's matrix multiplication we consider as theta of n square. So this is a time complexity of Stressen's matrix multiplication. Okay, whereas you can use your brute force or general method. So it will take the time complexity is theta of n cube. I hope you all understand. Thank you.